So, vectors, here we go. This is the big topic people often struggle with. And it's nice when you get into it and you get your head around it. It's actually just about pathways and is very useful for physics later on as well. But a vector describes both a direction and a magnitude, like a length. So key bits of advice for vectors. You can write vectors with this little underline. You can write it with an arrow above it. Or you can give what we call a column vector if you actually do know how much left and right, up and down it is. And that we use that for translations when we describe translations. But vectors is a really important end of the exam topic that actually can be really easy, or they can be quite nasty kind of proof questions. Something I just want to advise you all. There was a student at the school I work at a few years ago that they were doing A-level maths and further maths, and I think Cambridge like entrance exams, like step exams or something. So they had a lot of maths exams, and they unfortunately broke their wrist or something before the exams, and we had to get a maths scribe to do all these like 12 different exams. And the point was, the thing we kept emphasizing was make sure they underline vectors. That's something you need to know as well, so that the examiner knows it's a vector. Okay, so when you're describing vectors, you're not expected to develop a bold font handwriting. The thing you're supposed to do to format it is to underline that's a vector. So if there was like a scale factor in front of it, like K or something, you don't underline that or the number, but you underline the bit that represents the vector. So what I'm getting at is, even if the question uses a bold letter A, you don't write in bold, you just underline it, and that means the same. Okay, so that's just one little formatting thing to let you know. Now here, a regular hexagon, O to A is being called A, but we will write it like this. And O to B is B. Now they are different vectors. They may well have the same length, but they are not the same vector. That one is angled that way. So on here, if I said, where else have I got that same vector? Think of it as a pick-upable, movable little line segment. This here would also be A. This would also be A. This would not be A. This would actually be B. And this would be B. This would be neither of them. Horizontals. You have to think about how we define the horizontal using those little roots. So how would we describe A to B? Well, I don't invent another letter. I say, well, I can go back this way, negatively by A, forwards by B. So I can call it minus A plus B, or B minus A. And that now describes a horizontal movement. It's the same as going back by that much and forwards by that much. So here is a question to look at. I know the answer's in the corner, but I want to work this through. So what it says is OABC is a parallelogram. So OA is 4A. That obviously means that this is actually 4A as well. And that's 3C. And then it says CB, here's our ratio again, to BX, and we have to be careful, that to that, that to that, is the ratio 2 to 3. So this is actually 2/5 of the whole thing, okay? Which means I can actually work out the vector B to X. Now, if this is 2/5, if I divide it by 2, it's 2A, and times it by 3, this bit would be 6A. We all agree with that? Is everyone happy with that? Now, what we have is we're asked, y is a point such that C to Y is 2AX. Now, AX is this vector here. This, again, is where you have to take ownership and add it in. And C to Y is double that. So Y is actually like somewhere over here, because that vector is A to Y, A to X, and C to Y is 2 lots of that. So it's the same angle, but it's double as long. So let's think about, could you define A to X to start with? So A to X, and I'll describe it in terms of the pathway. that I take, I'm going to go A to B plus B to X. So that would be 3C plus 6A. So C to Y is just two lots of that. Which is, hang on, where have I gone wrong? Oh yeah, no, that's right. Now the question actually asked me for the vector O to Y. So if I want to go from O to Y, I need to go from O to C plus C to Y. So from O to C, I come along by 3C, and then I add C to Y, which gives me a total of 9C plus 12A. So it is about kind of owning these diagrams and adding anything on we can. Now, let's look at this one, because this is the kind of question we need to brace ourselves for, the kind of proofy questions. Okay, let me just see if I've got, yeah, this is a bit intimidating, this one. Okay, I'm going to walk you through, once in a blue moon, once every few years, a really nasty vectors question comes up about proof. And it involves actually simultaneous equations. So this is one of the hardest kind of questions we're going to look at. Then we're going to get onto the trigonometry tips and tricks. So brace yourself for this one, but I'm going to explain what happens here and how to get into the question. So this is about finding two different ways of describing the same vector. I'm going to try and walk it through with the pre-done annotations, but then if you've got any questions, just ask them as we go, and I'll repeat anything I've said. But basically, there's a lot of information here, and we've got to add it on where possible. It says OAN and OMB and APB are straight lines. You might think, okay, not a big deal, I can see that. But that actually means there's a lot of vectors that can be stretched to each other because they're all going the same way. N is the midpoint of OB. OA is A. OB is B. So actually that's a half B and a half B there. And it says A to P is K lots of AB. So it's saying that this is some stretch of AB. Can everyone see that K must be a decimal or a fraction? Because AP is smaller than AB, I've shrunk it, so K needs to be less than 1. This might be a half or a fifth or something, but K is a stretch of this that shrinks it down onto this. So AP is K lots of AB, where K is a scalar that we're trying to find. Given that MPN is a straight line, it asks us to find K. The first thing I'm going to do is add that thing on, MPN. And I've now got the key to this question, this type of horrible vector scale factor one, is to find two different roots to describe the same thing. Okay, so what I'm going to do is I'm going to think about describing M to P in two different ways. And I'm going to show you how to do this now. Let me clear this. So M to P, I can go like this, or I can think of it as some stretch of that whole thing. Do we agree with that? Please do bear with me on this, because I've really picked some of the nastiest questions that people can't approach. But the point with this is we need to define this vector in two different ways, using all the different lines we've got. So one thing I would set up to start with is, could we define the vector M to N? Because I do know that MP is some stretch of M to N. So M to N, I know I could go like that. I could go MP, oh sorry, MN is actually equal to minus a half B plus A plus, now it says AN is 208. So that bit there is 2A, and that bit there is A. So actually M to N, if we recognise, is a half B plus 3A. And I now know MP is some stretch of that. So MP is some scale factor of the whole length. And again, that would just be like less than 1 because I've shrunk it down. So what I'm getting at is I currently know how to describe from M to N, okay, going this way. And I know MP is some fraction of that. That's what I just said there. Now, what I need to do is define a different pathway, get from M to P, that uses a different scale factor, which is where K comes in. So I could go across there, and down there. So M to P could also be described as M to O plus O to A plus A to P. And I've used a different line. So M to O is minus a half B again. O to A is A. And A to P is K loss of A to B. And A to B I can actually work out. It's minus A plus B. Now, this is all the hard work, is what we're actually currently doing. We're setting up 2 different pathways, and it's looking already very confusing. As I've got this and a scale factor I've had to introduce to do with this line. Yes, I mean, we only have half an hour left. I think that we might take a couple of minute break. Yeah, if I whiz through this, and I'll leave this up. And then it's really just finishing with the trig and a little bit of a Q&A, but we only have half an hour of the session left. So yeah, we can pause after this. That's absolutely fine. Okay. Sorry, yeah, I do appreciate this being quite full on. Let me just let's carry this on. So what I'll do is I'll put the answer up for this full question and I'll talk it through where it's I've sort of pre-annotated it. And then if we want to take a break for a couple of minutes. So the 2 different pathways, I actually use, so I use lambda as the scale factor of Mn, and I described it 2 different ways. And what happened is if I do this MP method that I was just explaining, and then I get all the A bits together and all the B bits together, I can then directly compare it to the other method I used, which was going as a stretch of this. So I've described it one way as that path, here to here to here, and I've described it as a fraction of that path. And then the 2 expressions I've got, I've set equal to each other. And then it's just comparing coefficients. So then I know that the thing with B needs to equal the thing here with B, and the thing here with A needs to equal the thing here with A. And then what I do is I've created a simultaneous equation, like a linear simultaneous equation for lambda and K, which you can actually use your calculators for if they have the simultaneous mode. You could change them to X and Y if you want, if it helps you. And you get that lambda is a fifth and K is 2/5. And that actually sort of makes sense because it's less than 1. But that was like a really hard question to sort of rush through. I'll tell you what I'll do. If we could have 2-minute break, so we'll start back up at 2:36. 2:37. I'm not going to go anywhere because we only really have sort of 20-25 minutes left, but I will leave this on the screen for you to digest, take in, ask any questions, because I think the trigonometry bit we're about to do is really, really important. And then I'll answer any final questions. But yeah, just another sort of minute and a half. If you need a break, you need to use the toilet, get a drink, whatever, do that now. And I'll start up in a couple of minutes, but I'm going to stay here so I can see the Q&A. And I'll leave this screen on. Sorry, apologies for not taking a break sooner. I was just kind of aware we have a little bit less time now in the afternoon part. So this is quite a tough question. Do feel free to ask about any bits. But I wanted to show you the general setup involved using 2 completely different pathways and having the bravery of I need to introduce a scale factor. So if you have any questions about this, please do let me know, this particular one. Okay, in 1 minute, we'll be starting back up. Thank you again for all the questions throughout. And you've all done really, really well. Like sometimes I pitch this at quite a hard, quick pace, and especially online and trying to cover all the main bits of the GCSE. 30 seconds or so, and then we'll push on. And then hopefully they'll just be getting through the trig and the last little parts. But vectors can be really nice, easy questions. They can also be like this, which, every now and then kind of comes up. And it's always this